All right, Bismillahirrahmanirrahim. So today we are just going
Hello,
to go
sir.
for the practice session. Yes, Assalamu alaikum, Mustafa.
Sorry, it's my mic. I don't know why it was playing games with me.
All right. So today we are just going to be talk about the practice of proof. So let's see have to be quiet. All right. Now we have a first question. He says that in a mathematical argument, how are three consecutive integers usually denoted algebraically? Yes, Wajih Khunam. How we can show the three algebraic numbers, three consecutive integers. Yes, Vijay Khurram, you have the idea? You have done it. Yes, Mustafa, you have idea?
Yeah, n minus 1, and then n plus 1.
Yes. It will be n minus 1. The middle number is n, so you have to take the one previous number, 1, after number. In a mathematical argument, how is an even number usually denoted? And similarly, how we have to be show the odd number denoted. So we have to show the even number by, yes,
2n.
Mustafa, it is going to be multiple of 2.
2.
And the odd number is denoted by,
2n minus 1, or you could use plus 1
e-
as well.
yes, normally we have to use 2n minus 1. All right, prove that the sum of the two odd numbers is even. So we have to take the one odd number is going to be 2n minus 1, and there is another odd number that is 2m minus 1. So let we have these two are the odd numbers. So we have to take their sum. We have 2n minus 1 plus 2m minus 1. So it is 2n plus 2m minus 1, it will be minus 2. So look at here in these values, I can easily take 2 as a common. So we'll get n plus m minus 1. So this is the multiple of 2, means it is even number. So this is the thing that we need to prove if we are just going to be taking the sum of two odd numbers. So their answer will be even. Explain why x minus 3 whole square is greater than or equal to 0 for all real numbers. Okay, here we have to explain. So we know that if you have to take the square of any real number, if you have any negative value, or for example, if you have x minus 3 is equal to a positive answer or positive value, so we know that the positive value multiplied by positive value, the answer will be positive. In the same way, if you have, for example, the answer of x minus 3 is a negative value, so but because we are taking a square, so it means that negative value multiplied by negative value minus the minus is plus, so the answer will be positive something. So that's why it in short we can say that if you have any number having a whole square, the answer is going to be always positive. Next, he says that prove that the product of two even numbers is a multiple of 4. So, yes, Wajih Khurram, are you here now? Yes, Anuj. How we can show the two even numbers?
Yeah, one even is 2n plus 1
So let's two even numbers are 2n, not plus
minus
1.
1
No, we are not talking about the odd number. The product of two even numbers. So let's say 2n and 2m. He says that if you have to take the product is multiple of 4. So their product is equal to Product is equal to 2n multiplied by 2m. So 2 times 2 is 4, it is nm. So clearly we can see that the km is obviously the n and m are the integers. They are the positive integers. So obviously if you have to multiply them, you will get k multiplied by something. So this means that it is multiple of 4. Yes, everyone. Any question till here?
No, sir.
Yes, Ishal, Aisha, Vijay Khurram.
No,
No,
sir.
sir.
No, sir.
All right. Now, next he says that use a counter example to show that the root of x square is not equal to x. Okay, we have to give the example that the answer of this value is not going to be equal to x. We have to take any variable. I'm just going to take x is equal to
Minus
minus
2.
2. So, in the same way, you have to take the minus 2 square. If you have to take the root of minus 2, that will become
The total
4.
answer will become 4 and then 2.
And the answer of the 4 is 2. Look at here, we have to take the minus 2 square, and the answer is going to become 2, and that is not equal. So this means that this is the counter example that in general, the root of x square is equal to x. That is not true in general. Go for the next one. Prove by exhaustion all possible factors that 11 is a prime number. Okay, so we have to do it step by step. We have to show that 11 is a prime number, so we have to be check that 11 must be divisible by 1, divisible by 2, divisible by 3, divisible by 4, and then it will be multiple of this one. After midpoint, we have to directly jump to the 11 value. So 11 divided by 1, it is 11. Look at here, it is divisible by 1. 11 divided by 2, it is 5.5, it is not divisible. 11 divided by 3, it is something not visible. 11 divided by 4, it is not divisible. 11 divided by 5, it is not divisible. So look at here, he says that all possible factors. So 1 is the factor. It is not a factor. It is not a factor, not a factor, not a factor. And after that, it will be because we have to move till mid. After mid, obviously, we have to be go jump to the 11 by 11, that is 1. So it means that 11 is also the factor. So look at here, this number having a two factors. 1 is the factor and 11 is the factor. So if any number having a factor 1 and itself, that number is known as yes everyone. If any number having only divisible by 1 and 11, that number is
Prime.
prime number. So it has two factor 1 and 11. So 11 is a prime number. In the exhaustion method, I told you have to take all the possibilities and accordingly you have to solve it. Next, he says that prove that k square minus 6k plus 9 is greater than 0 for all real values. Okay, we need to be sure that it is. So we are just going to be do it by, yes, which method we will use? Anyone? How you can prove that this value is greater than 0? Which method we will use?
Greater than, we can use quadratics.
Not quadratics, we will use the deduction method. In the deduction, we have to use the algebra and logics. So first of all, I just need to rewrite this value as a in the completing square form, because I know that if any value is going to be a whole square, so that always be greater than 1. All right. So k plus minus b whole square, I know it to be write it in this form: x minus plus b whole square minus b square. All right. So it is whole square minus b square plus 9 as it is greater than 0. Now what is b? B is the coefficient of x, so it is minus b over 2. So minus 6 over 2, that will be minus 3. Yes, everyone, you know that how to do the completing square? Is there anyone here who don't know how to do the completing square?
Yes,
I ju
you divide 6 by 2, so you get 3. So you write,
yes, yes, I need to be write the
yeah,
value in this format, okay? What is b over 2 is minus 6 over 2, the coefficient of x. So it is minus 3. So at the place of this one, I'm just substituting minus 3. So I will get that k minus 3 whole square. It is minus 9 plus 9 is greater than 0. So I'm going to get k minus 3 whole square is greater than 0. So obviously we know that if any number having a whole square is greater than 0 means it is k
Yes.
minus 3 whole square is always
positive.
greater than 0 for all real values of k. Yes, Simon, it is clear.
Yes, sir.
Yes, Ishal, Muhammad Ikram, Aisha, Vijay Khunam, Manoj.
Yes, sir.
Okay, he says that show that 0.6 can be written in the form of p over q. So it's very simple. It is 0.6. To write decimal, it is 0. So it will become 6 over 10. So look at here, we are able to write this value. And what does this tell you about the type of number is? So a number that can be written in the form of fraction, that is known as rational number. All those numbers that are possible to write into the form of fraction, they are known as rational numbers. Yes, everyone, please do it on your notebook. The three consecutive integers is a multiple of 3. So take one number is n minus 1, and n minus n plus 1. Please do it on your notebook and set the working.
Okay.
So you do n minus 1 plus n plus 1.
Uh, just do it the working on your notebook and send
One
it.
second.
It is n, it is n minus 1, and the third integer is n plus 1. You have to say that their sum is multiple of 3. Yes, any other one done the question?
Yes, sir, I sent it.
Sir, I'm just sending.
Okay,
Sir, I sent as well.
all right, 1 minute. Let's see. Why it is n minus 2? Okay, but normally you have to take n minus 1 and n plus 1. That would be the suitable choice, okay? However, it is correct as well. All right, all of you. Those students who've done the first part, first question, go for the next one, please. Question number 11. You have to do it by deduction method as well. Use your algebra skills and prove that this is going to be greater than 0 for all the values of x. Yes, those students who have done this part, you have to use a very basic algebra here. No, Aisha, we don't do it by this way. Basically, you have to prove that x is greater than 0.
Hmm.
Yes, all right, everyone. So basically, it is positive 2, on the other side will be negative 2. So you will get that x square is greater than or equal to 0. So obviously, if is greater than or equal to 0, it means that the answer is going to be always.
Self-centered. Sir, is your light out?
Assalamu alaikum. Hello.
Walaikum assalam.
All right. Sorry, everyone. Basically, just the electricity goes, and my electric heater will be on my UPS, so that's why the UPS will be shut down. Can you see the screen?
Yes, sir.
All right, so we'll talk about here till here. Okay, I will do the question now. Prove that the square of an even number is a multiple of 4. So let we have an even number is equal to 2n. So we have to take a square. So that will be 2n square. That will be 4n square. So clearly it is a multiple of 4. The set of the number s is defined as all positive integers less than 5 and prove by exhaustion that the cube of all values in s is or lesser than 100. So in the exhaustion we have to take all the possible values. The positive smaller positive integer is 1. So 1 square will be 1. It is 2. 2 square will be 4. Sorry, cube. It says that we have to take the cube of all values. So the 2 to cube is 8. Yes, what is the 3 cube?
27.
It will be 27. And if we had to take 4 cube, yes, 4 cube will be equal to
64.
64. So look at here. All values are less than 100. All right. Next, he says that use a counter example and prove that the difference between any two square numbers is not always odd. So the difference between two square numbers. So yes, one is a square number.
N square.
Uh, we have to do it by the counter example. We have to look for the example that we will take a square. This two square numbers. One is a square because it can be written as 1. 4 is a square number because it can be written as 2 square, right?
Yes.
Think about the numbers that which are the numbers that we are able to write into the form of square.
4 and 16. Would that be correct?
So yes, which are the two numbers we have to take the difference and it will be not odd.
You can
Is
use
all
16 and 4.
16. We can take 9 minus 4 as well. It is 5. And we have to take the 16 minus 4. That will be, yes, that will be equal to 12.
12.
Is even number. Yes, everyone. It is clear?
Yes, sir.
Yes,
Next, he
sir.
says that express 18 as a product of its prime number. It's very simple. It is 18, 2 times 9 is 18, 3 times 3 is 9, 3 times 1 is 3. So 2 times 3 square. Write all the prime numbers between 1 and 13. So, yes, what is the smallest prime number?
1,
1 is not a prime number. So for the prime number, we need at least 2 factors, and 1 have only 1 factor.
2,
Yes. 2, 3, 5, 7, 11. So by dividing 13 by each of the prime numbers found in part B, prove that 13 is a prime number. So obviously 13 divided by 2, it will be, yes, 13 divided by 2 is equal to 6.5.
6.5.
13 divided by 3, that will be 4
4.37.
4.33 or 4.37.
Wait 1 second. It's 4.33 recurring.
Yeah. So 13 divided by 5, that will be equal to 2.6. It is right. Yes, everyone. It's a very simple
1.86.
1.86. Okay, and 13 divided by 11, that will be equal to
1.18 recurring.
1.8. So look at here, it is not divisible. So 13 is a prime number because it is divisible by 1 and 13 only.